Previously, we solved the same circuit using circuit reduction, just like so. And then in the previous video, we saw our voltage divider, right, like so. And now we're going to solve using KVL. And we're going to show you KVL will give you the same answer. Now, KVL is a little more complicated. It really requires a little more understanding, okay? But we're going to solve KVL. So one of the things in KVL, okay, is you're going to draw your current, but you're going to draw your current in a circle because you have a loop, okay? Your current's operating now in a loop, which is the same thing as going in a straight line, okay? It's the same. But we're going to go ahead and analyze this, and we're going to determine how this KVL works. And this stands for Kirchhoff's, and you can spell it in different ways, but Kirchhoff's voltage law. Okay, the way Kirchhoff's law works is you write sum of the voltage across the loop is equal to 0. And what we're going to do is we're going to travel across this loop, okay? And we're going to write is equal to. Now, the way this is going to work is we have to first thing we want to do in our Kirchhoff's voltage law steps is one is identify all loops. Okay, and these are our steps. So there's only one loop here, so that's loop 1. The second thing we want to do is we want to label all voltages. Okay, when you label our voltages, so our voltage here is obviously VS1. When the current travels around, obviously this is going to be what? VR1. When the current travels around here, what will this be? VR2. Okay. Now what we want to do is called sign convention. What is our sign convention? Our sign convention is simply what sign are we going to use. Now, obviously, we have two different polarities. We have a positive, negative, positive, negative. I prefer the second sign convention, which means the second sign after the current passes through. You can choose the first sign convention is all the same. So what we're going to do is our sign convention can be first or second. But whatever you prefer, I prefer second sign. As soon as I know it's second sign, okay, the way this would work is I go back and I say, okay, this is my second sign. This is my second sign, and this is my second sign. Okay, so we type in plus VS minus VR1 minus VR2. Okay, now what is my VS? That's 10. That's easy. Okay, well that's 10, right? I'm going to write down 10. What's my VR1? I don't know what that is. What's my VR2? I do not know what that is. So what do? Plus 10 minus VR1 is V is equal to IR, right? So I type in IR1. Here, I do not know what VR2 is. So I write IR2 because V, I'm going to put a note here, V is equal to IR. And that's equal to 0. So if I don't know what it is, I default to V equals IR. And since R across this voltage is R1, I write R1. Since R across this voltage here, R2 is R2. I write 10 minus I R1 plus R2 is equal to 0. Okay, Now there's a little bit of algebra. We can just do the combination here. What is R1 plus R2? Or you can just say, you can just plug it in. Those of you who are not familiar with algebra, if you really don't, if you don't feel comfortable with it, which is fine, all right, we can just do it the little longer way. You can erase it. Times 10 minus I times 5 is 0. 10 minus 15i is equal to 0. So that's 10i plus 5i. Okay, so this goes across, so that's, we can write minus 15i is equal to minus 10. I is equal to what? Minus 10 over 15, minus 15, which is 10 over 15, which is equal to 0.67 amps. Okay, I'm sorry, 0.67 amps here. Okay, so now what happens? What happens here? .67 So we have to now calculate our voltages. Well, what is voltage? Well, we simply say, previously, remember V equals IR? So VR1, voltage across resistor 1, is what? IR1. Which is what? 0.67 times 10, which is 6.7 volts. V of R2 is IR2, which is 0.67 times what? 5, which is roughly 3.35 or 3.33, whatever. Well, roughly this is going to be 3.3 plus 6.7, which gives us 10. Okay, so now you can see how the circuit is solved. You can solve it using KVL, and KVL is the method. This is probably the method you got to master, because as the circuit gets more complicated, you got to be able to do this. Okay, all right. You can solve it using voltage divider, just like that, and you can solve it using circuit reduction. Notice you will get the same answer. Okay, so here I can see my voltage divider. I got the same answer with VR1, VR1, VR2, VR2. .7, 6.7, 3.35, 3.35. Okay.